This protocol provides the first example of visualizing the rotation of a man-made light-driven molecular motor at a single molecular level. The synthetic technique used here is designed to allow the synthesis of a complex molecular machine with several functional groups.
First, under an argon atmosphere, place 640 milligrams of the rotor precursor compound 2, 219 milligrams of copper iodide, and 3.44 grams of sodium iodide in a 100 milliliter Schlenk tube equipped with a stir bar. Connect the sealed tube to a Schlenk line and add 50 milliliters of 1,4-dioxane and 263 milligrams of trans-1,2-diaminocyclohexane. Stir the mixture at 140 degrees Celsius for 24 hours to exchange the bromine substituent for iodine. Then, let the mixture cool to room temperature and evaporate the solvent under vacuum. Purify the compound by silica gel flash chromatography and remove the volatiles to obtain the iodine-substituted compound 3 as a sticky yellow oil. Next, place 415 milligrams of Lawson's reagent and 219 milligrams of compound 3 in a Schlenk flask equipped with a stir bar. Connect the flask to a Schlenk line via a condenser and purge it with argon 3 times. Add 10 milliliters of toluene and reflux the mixture for 2 hours to convert compound 3 to a thioketone. Evaporate the solvent and purify the thioketone by flash chromatography. Remove